Good morning and welcome to this morning's special edition of the Signpost webinar, where I'm joined by Teagasc colleagues to launch and outline key findings from the National Farm Survey Sustainability Report. The webinar will be slightly longer than usual and will run to 1.5 hours. And the webinar marks the beginning of Teagasc Signpost Sustainability Month, where during the month there will be a range of on-farm events, predominantly on our signpost farms, and a number of online events also. And for details of that, you can Google Signpost Sustainability Month. I'm delighted to be joined by a range of colleagues. Professor Frank O'Mara, Director of Teagasc. Frank, you're very welcome this morning. Kevin Hanrahan, who is head of the Rural Economy and Development Programme in Teagasc.
Good morning.
Trevor Donnellan, head of the Agricultural Economics and Farm Survey Department. Morning,
Good morning,
Trevor.
everyone. Morning.
Cathal Buckley, who is the researcher and lead author of the NFS Sustainability Report. This is not your first gig this morning. Anyone who was up bright and early may have heard you on RT at about 7:10 this morning. So hopefully this will be a little bit more relaxed this morning.
Thanks, Pat.
And Simon Leach, biodiversity technologist, who will be looking at biodiversity on development on NFS Farms.
Morning.
Frank, I'll come to you first. I think the sustainability report is part of the NFS. I think the first short report was 2013. 2013. So this is the 10th year. I don't think we've had a report every year, but it's 10 years since we started this report. It's become a key part of the NFS and of key importance to the agri-food industry.
Absolutely, Pat, and good morning, everybody. And look, I'm delighted to be here at this, and it's a great actually way to kick off the Sustainability Month in Teagasc, because this is a key report that we do, and it actually pulls together an awful lot of information around sustainability. And look, we all know sustainability is really, really important. And I suppose often when people hear the word sustainability, they immediately jump to things like climate change or water quality. And absolutely, the environmental side of sustainability is very important, but so too are the other two pillars of economic and social sustainability. And this report covers all three. And what it is essentially is using the data that's in the National Farm Survey. And that's a long-running survey. It's running for 50 years now. It's a representative set of Irish farms, and about 1,000 farmers in it. And it was established. It's a statutory requirement of Ireland to do that as part of our EU membership, so we can report on the farm income situation on Irish farms. So what we've done is we have, over the last 10 years at this stage, we've also used that information and collected some extra information on our farms to allow us to get a broader view of the sustainability of our farms. And so that's, I suppose, adding on the environmental and social aspects of sustainability to the information on incomes. And that's what we're launching here today. And as you said, Pat, it's 10 years since we launched the first one. It's actually our 8th. You know, we didn't maybe at the time intend to do it every year, but it has become so important that we have turned it into an annual series. And that's very much part of its strength now, is that we do have 10 years of data, and that allows us to track progress over time and see how things are changing and what's driving those changes, and I suppose smoothing out the impacts of shocks to the system, whether that's weather shocks or price shocks or whatever. So that's what today is, and that's why I think it's actually a great event to kick off the Sustainability Month. And I very much compliment my colleagues in the Farm Survey Department and the Farm Survey itself, and Cathal as the key driver of this report for having created this really valuable analysis of the sustainability of Irish agriculture, going back, as I said, now over 10 years. And we're actually leaders in the EU in this. One of the goals of the famous Farm to Fork strategy is to turn this network that is around the European Union of accountancy information, the FADN as it's called, the farm accountancy and data network to turn that into a farm sustainability data network. So look, Teagasc and Ireland were one of the leaders of starting that initiative, and now it's, as I said, one of the goals of the Farm to Fork strategy. So it's part of a European, I suppose, project at this stage. So look, I'm not going to go into
one of the things I looked at that first report, and one of the things that's seems to be constantly happening is an extension of what's being looked at in the report, the criteria that are being examined, and that's been, I suppose, the story of the first 10 years of the report, that it's expanding in importance and in significance, but also in terms of scope, and we see that this morning with biodiversity being taken on board.
Absolutely, yeah, and I suppose we knew we had a rich source of data, but obviously we did need to add additional things to it. So, for instance, we weren't collecting information in the past on the type of nitrogen fertilizer being used, and that's obviously very important now to see what proportion of our fertilizer is low emissions type, as in protected urea. So we certainly added to the data over the years, and one of the things that we would really like to crack is the whole biodiversity an evaluation on the farm, so that again we could get a countrywide or an agriculture-wide picture of the biodiversity status of our farm. So look, this is not a complete analysis yet. We will continue to improve and refine this over the coming years.
Okay, thank you very much, Frank. I then go to Trevor. I think, Trevor, you will give us a presentation and put a bit of context on the report.
Okay, I will do that now. Just give me a moment.
While Trevor is just getting ready, I just remind you that if you have questions for any of the presenters, to use the Q&A, and we will go through the presentations, and we'll have hopefully an extended Q&A session at the end. So, okay, Trevor, if you want
to you can see those slides, Pat?
Yes, perfectly.
Okay. Well, good morning, everybody. I'm not going to delay proceedings overly long here. I'm just going to talk to you for about 10 minutes about the background policy context to what we're doing here, and also maybe for those of you tuning in who are less familiar with the National Farm Survey, just to give it a brief little summary around that. And as the director mentioned as well, this transition to the farm sustainability network that's happening at a European level, I'll give that a short mention also. So just for context, the Teagasc National Farm Survey has been around since 1972, so it goes all the way back to when the Teagasc predecessor on First Taluntas was in existence. So it was established as part of our entry into the European Union, and there are analogous data collection activities taking place right the way around the European Union. The philosophy behind this originally was to so that the European Union could be sure of how its funds for agriculture were being spent, and gathering data on farmers' incomes was considered to be part of what needed to be done in that regard. I'll talk a little bit shortly about this transition to a farm sustainability network. That's something that was perceived to be quite important in the context of this EU Farm to Fork strategy, which aims to produce a significant improvement in the environmental performance of agriculture across the European Union. My colleague Cathal is going to talk in detail later, and one of the things that I guess we want to convey in this discussion is that when we're talking about sustainability, we're talking about economic, social, and environmental data. Sometimes when people discuss sustainability, they can find the discussion to environmental issues. We'd be strong on emphasizing that to have a sustainable agriculture sector means that you need to achieve objectives that are economic, social, and environmental. So why are these three strands of sustainability important? What is all the fuss about in respect of sustainability? Well, if you just look at economic sustainability, if you have a sustainable agriculture sector that can contribute to things like job creation, it can improve generational renewal, it can contribute to economic growth, it has benefits downstream in terms of employment in food processing and distribution. You can enhance food security as well. From the environmental point of view, sustainability is very important in the context of the preservation of our natural resources, reductions in pollution, reducing greenhouse gas emissions, which we know now is a huge issue, and the protection of our water and biodiversity. And then in a social context, we're talking about supporting the well-being of the farming community and society at large. We want to ensure that farming is an attractive livelihood in the context of things like work-life balance, and that's particularly important, I think, for younger generations coming through. So in the context of policy, what has been happening over the last 12 months? Well, we have a few things here which I'll just highlight. At the national level, we already have preparation in place to produce the next climate action plan, the climate action plan for 2023. Also, there's work underway to produce carbon budgets that would extend beyond the year 2030. So people on the call may be aware that there are already greenhouse gas reduction targets for the agriculture sector to be achieved by 2030. And these discussions will look at what sort of targets will exist right across the economy beyond that point, out towards 2040 and even 2050. At EU level, the EU Nature Restoration Law has received a lot of media attention. Just for context, it's part of the EU's biodiversity strategy, and it targets the restoration of ecosystems. So when the Nature Restoration Law is eventually put into place, EU member states will be required to produce nature restoration plans as part of that process. And then finally, and as was mentioned by the director, we have this Farm Sustainability Data Network. A regulation is currently going through in Brussels to put that in place, and that will widen the range of farm data that is collected right across the European Union, taking it into the sphere of environmental and social data. We're actually fortunate in Ireland that we're further down the tracks than many other countries are in that regard. Some member states have very little data at a farm level in terms of the environmental performance of their farms or the social sustainability of their farms. And the other objective here of the Farm Sustainability Data Network is to modernize the data collection process that is used across the European Union. We're now into a new era of the CAP. As of the 1st of January, we're into a new CAP, and this new CAP at the member state level has required the creation of a CAP strategic plan. So this is something that has been created right across the European Union at the member state level. And the focus of the CAP strategic plan is on the delivery of 10 specific CAP objectives, which I'll mention briefly in the next slide. And those CAP objectives largely break down into economic, social, and economic challenges. And the data Cathal will talk about in his presentation will reflect where we are in terms of our agriculture sector in meeting some of those challenges. And one of the things we need to keep in mind as well is that even though we're talking here about the common agricultural policy, increasingly it's being influenced by wider policy at the European Union level. At the top, we could think about it being the European Green Deal, which has a substantial ambition to place the European Union as a leader in terms of environmental improvements right across the economy and not just in agriculture. The Farm to Fork strategy is a specific strategy that relates to the Green Deal and is focused around agriculture and delivering environmental benefits through a more environmentally compliant agricultural production system. And then finally, you have the biodiversity strategy, which aims at restoring biodiversity in our landscapes across the European Union. So these are all influencing how the CAP is evolving. So our 10 objectives are shown here in this circular diagram on the right, and they break, as I said, largely into three groups: the economic group, which you see near the top, the environmental group over to the right, and the social group down at the bottom there. And then we have a 10th one, which is called knowledge and innovation. And knowledge and innovation is seen, I guess, as a cross-cutting type of objective. And the view is that if we can improve the dissemination of knowledge and innovation across the agriculture sector, that will then contribute to more successfully achieving the other 9 objectives. So in the context of this new CAP, what is happening exactly? Well, we still have our 2 pillars of the CAP. That structure has been maintained. The total support for Irish agriculture annually will be in the territory of about €2 billion per year, with 1.2 billion of that falling into Pillar 1, and I'll explain that in more detail in a moment, and the residual then falling into Pillar 2. So just to discuss what's happening under Pillar 1, it's broadly the same amount of money that existed under the previous CAP, but there are new structures in place in terms of how farmers receive that level of support. The single biggest chunk of that support is going to come in the Basic Income Support for Sustainability, or BIS, and that mechanism is the primary income support mechanism that will exist in this new CAP. Importantly, we have the introduction of what are called eco schemes now under Pillar 1, and these eco schemes will pay farmers for engaging in activities which will have positive environmental benefits. So that's a key change relative to the previous CAP. And then we also have 2 other important strands, one relating to support for young farmers, and finally at the bottom there we also have a support payment which steers support slightly towards smaller farms. Under Pillar 2, the total amount of funding is higher now than it would have been previously. The Irish government will also make a bigger contribution under Pillar 2 than would have previously been the case. It will continue to support leader companies, but there's also this important replacement for GLOS under Pillar 2, the Acres scheme, which people are probably increasingly becoming familiar with. The overall aim in that context is to even drive further the environmental improvements that can be achieved in agriculture. Under Pillar 1 now, farmers are expected to achieve specific standards in relation to environmental compliance, and farmers who sign up to the Acres scheme are essentially saying that they will do even more in terms of promotion of positive environmental impacts within the agriculture sector. There are also some other supports that are worthy of note. Increased support for organic farming, and in a future report we hope to be able to produce detailed data on the sustainability of organic farms as well. So if you tune in this time next year, you might find us talking about that. And then just finally, to introduce what Cathal is going to talk about, we're going to have a discussion of our 4 principal farm systems: dairy, cattle, sheep, and tillage. Cathal will go through a lot of indicators as part of the discussion. I guess the key point to take as my final remark is that this is just a flavour basically of what is in the National Farm Survey. I think I'm right in saying that we report something like 1,600 variables to the European Commission, and we have a whole range of variables in addition to that associated with environmental and social sustainability, which increasingly will be reported to Brussels as well as part of this transition to the Farm Sustainability Data Network. So I'm going to pass you back now to Pat at this point. Thank you.
Thanks very much, Trevor. The policy context is not getting any simpler. The requirements are, I think, growing all the time, and that's likely to continue in this space. So it's not going to get any easier. Cathal, if you would just then give us the outline of the sustainability report.
Hey, thanks, Pat. Can you hear me okay?
Perfectly there.
Okay.
No, it's gone again.
Okay.
Perfect.
Thanks, Pat. So, as Trevor says, I'm going to go through the results for 2022. By way of, I suppose, overview of the presentation, I'm going to start with the theoretical framework, and Trevor has touched on this already, go through the methodology, the results, and then offer some conclusions and discussion at the end. So in terms of the framework, okay, the way I like to conceptualize this or frame it is sustainability is really analogous to a three-legged stool where you have the economic, environmental, and social legs. And to be truly sustainable, a farm has to be strong in those three dimensions. Trevor mentioned earlier, we do have kind of a stable, kind of a buttressing dimension, which is called innovation, which helps to stabilize the other three legs of the stool. If one of those legs isn't stable, the system is rocky, and ultimately you're in danger of sustainability failure. So it's, all three legs have to be accounted for in any holistic sustainability assessment. Just want to touch on the data we use to generate the results. We, as Trevor said, we're reporting across the main land-based systems of production: dairy, cattle, sheep, and tillage. In 2022, our sample size was 774, a little down on previous years. We had some of our long-established farm recording staff retired, and I'd like to pay compliments to the remaining staff, and particularly the new staff who were hired to replace them, who have done Trojan work to get us to that number. We weren't sure what kind of numbers we'd have in the end, so I'd like to acknowledge their Trojan work in getting to that number. Those farms represent 84,000 farms nationally. A couple of things I want to point out, because it'll help in terms of kind of explaining some of the context of the results later on, is that dairy and tillage farms have larger farm sizes compared to the dry stock sector. Even though these farms are classified based on their main output, so sheep meat and crops and so on, but these farms have a significant cattle enterprise. That becomes important when you see some of the emissions profiles later on. Dairy also, but the vast majority of those dairy livestock, what we call cattle livestock units on dairy farms, are actually replacement animals for the dairy herd, or breeding stock. And as we can see, the stocking rate is significantly higher on dairy farms than it is on the cattle and tillage farms. So in terms of some housekeeping, when you see a diagram like this, essentially we're showing the 90% distribution of results. So the box in the middle is your interquartile range, the 25th to the 70th percentile. The line in the middle is the median, and the whiskers are the 10th and the 90th percentile. When you see a diagram like this, we divided the results by economic performance based on gross margin from the top third, middle third, and bottom third. When you see a graph like this, we're contrasting across systems. So throughout the presentation, tillage will remain green, sheep will be purple, cattle will be red, and dairy will be blue. And when you see the graph like this, we're basically presenting results on a 3-year rolling average basis. Why are we doing that? Well, the director touched on it earlier on. We're trying to account for short-term price and weather shocks, positive and negative. So you could see a spike in 1 year, and it could be related to a price or weather. So this kind of an approach kind of smooths out the noise in the data, and you can kind of discern long-term trends. That's not to say we're not hiding anything. All the individual year results are actually at the back of the appendix in the report itself. Okay, so starting with the first leg of the stool, the economic branch, we're reporting on gross margin per hectare and gross output per hectare and gross margin. 2 income-based indicators: family farm income per hectare, but also family farm income per unpaid family labour unit. And finally, to then relate to how much of the farm output is derived from subsidies, and how much and whether the farm is economically viable. And I'll get into the definition of this in a while. Okay, starting with the 3 land-based metrics: gross output, gross margin, and family farm income. You can see in the blue that it's not a new phenomenon, that the dairy farms have significantly higher gross output margin and family farm income on a per hectare basis. So that's not a new story. If you look at the graphic on the right hand side, this is the long-term trend, where you can see that gap between dairy tillage in the middle and the dry stock sectors at the bottom. It's been a fairly well long-established trend. What we are seeing that is the dairy and to extent tillage are actually been trending up towards the end of the time series. So the returns, the economic returns to dairy have been trending upwards. Okay, so what we're seeing here is the contrast between different systems. But I want to show you something in relation to this. Is the the family farm income on dairy farms divided by top, middle, and bottom by gross margin. You can see there's significant variability within systems. So we have variability across systems, dairy, cattle, beef, and sheep, but also you've seen huge variability within systems, as you can see here from the dairy profile. Okay, but the second one is I want to touch on is the productivity of labour. So this is family farm income per unpaid family labour unit. So how much labour is going in there from the farmer, the spouse, any kids or other family and so on. So the gap actually between tillage and dairy narrows significantly when you do it on an unpaid family labour basis. Why is that? Because there's about 1.5, 1.6 labour units going into family labour units going into the average dairy farm compared to about 0.9 for the average tillage farm. So when you do it on a per labour basis, the gap narrows between those two systems. Look, the cattle and the sheep are still lagging well behind these two. That's a fairly well established trend in the data. The gap, but also both those systems have been trending up in the last couple of years due to I suppose higher output prices in 2022 in particular. We'll probably see a reversal of that in the coming year where things are going. Also, I was going to say this is the distribution of the results across the different systems: dairy, tillage, cattle, and sheep. And you can see, even though there's variability across systems, the within systems variability is significant as well. So there's an awful lot of stuff going on across systems, but even within systems. So the final economic one I want to touch on is economic viability. So it's kind of a yes, no, 1-0 criteria. Farm is said to be economically viable if they can return the minimum wage for the family labour employed and give a 5% return on non-land-based assets. Non-land-based assets being machinery, equipment, and so on, and buildings. The minimum wage was $10.50 in 2022. So again, we're seeing a divergence between the cattle and the tillage and dairy. Because of I suppose the good year dairy had, about 95% of them are economically viable. About 80% of the tillage farms, 85%, whereas the cattle and sheep are down around 25%. And that's, again, that trend is fairly well established in the time series, but it's been trending up slightly for dairy and tillage in recent times. A little bit for the sheep and cattle, but they're consistently around 25% or so in terms of viability. A lot of them seek off-farm employment on the back of that. Okay, so moving on to the second leg of the stool is the social sustainability dimension. So we've three indicators in relation to the household, whether a household is vulnerable or not, whether they're an isolation risk, or whether they're high age profile. We have one in relation to whether they've received some sort of formal agricultural education, and finally then two in relation to hours worked. So how much hours are worked on the farm, and then how much work total hours in terms of on and off farm employment. So, okay, going on to the first one there, I'm going to touch on a few of them, not all of them due to time constraints, but in terms of the household vulnerability, if we go back to the economic viability definition, if a farm is not viable and if they have no off-farm employment, then they're said to be vulnerable. And again, it's a 1-0 yes/no bar. So we're kind of seeing the reverse of what we saw on the economic side in terms of dairy and tillage farms being less vulnerable. Because a lot of them are economically viable from that perspective, but you get the reduction in terms the cattle and sheep farmers are more vulnerable, but less so in terms of a lot of them off-farm employment. I mean, around 30% of them are neither economically viable nor have off-farm employment, which is concerning. But again, the trend in time series is generally well established. Okay, we are seeing a decline in vulnerability in the cattle and sheep systems in recent times, which is a good news story. And the final two on the social side I want to touch on are the hours worked. So if we just look at the hours worked on farm, you can see on the red bar there, look, there's a significant gap between dairy and other systems on a on-farm labour basis, about 1,000 hours. But and we know labour is very labour intensive. But when you account for off-farm employment, because nearly half the farmers in cattle, sheep, and tillage systems have some type of off-farm employment, and a lot of their spouses have as well. So when you just on the farmer basis, the gap between the total hours worked isn't as significant from dairy and others, but it is still a couple of hundred hours more on dairy farms. I suppose the concerning trend from my perspective is that that's trending upwards. Like, you know, the those hours being put on by the farmer onto dairy farms has been increasing over the time series, which is a concern from a work-life balance perspective going forward. You know, how far can they push that envelope in terms of hours worked on the farm is an open question and a concerning one. This is a graphic my colleague Emma Dillon and Brian Moran generated. Basically, we have a look at certain social sustainability indicators on a one-stop basis year on year. I'm not going to dwell on any huge detail on this because I wouldn't do it justice. So I can refer you to Emma if you want to follow up. But like we've taken temperature on farmers in terms of how often to take a break from the farm, when they last visit a doctor, how regularly they have contact with people outside the farm, whether they get help or not, and portion of farms with female labour input in 2022. So there's a lot of detail there. It's in the report, and if you have any follow-up questions, I'll defer you to my colleague Emma Dillon. Okay, so the final leg of the stool then is the environmental branch. So look, we report on gaseous emissions, both greenhouse gases and ammonia. On the greenhouse gas side, we do it on the IPCC, the same as the EPA National Inventories approach, but we do it on a farm basis. We also have a life cycle assessment on the dairy side. On the second environmental dimension is the risk to water quality. So we're tracking inputs and outputs through the farm gauge to see how efficiently farmers are using their nitrogen and phosphorus, because higher surpluses are, all other things being equal, are higher risk to transfer to both the atmosphere but also to water quality. Finally, we're developing a biodiversity indicator, and I'm not going to dwell on this because Simon is going to outline this in a lot more detail in his presentation. Okay, so we report, I think, like something like 16 indicators on the environmental side, on the greenhouse gas, the ag-based and energy-based emissions from per farm, per hectare, per kilogram of product, be it meat, milk, and so on, and sheep meat, and euro of output, and the same for the energy side. On the ammonia side, again, per farm, per hectare, per kilogram of output, and per euro of output. And on the risk of water quality, NMP balances and use efficiencies. I'm going to touch on some of these in the time I have in terms of the trends in recent times. Okay, so why are we reporting in different levels, I guess? Okay, when we're reporting farm and per hectare levels, we're essentially reporting absolute emissions, like has the emissions on farm and per hectare increased or decreased. And we're reporting on per kg of output and per euro of output. We're actually looking at the carbon footprint of that production. You know, is based on the amount of product being produced, is the footprint of that product going up or down? Both those two reporting frameworks are important to see what's happening in the overall scheme of things. Okay, so jumping into some of the results. So for 2022 for dairying, we're seeing with a slight reduction on the previous year, 606 tons of CO2 equivalent, majority of it coming from milk production. The cattle side there generally is to do with replacements. It is on dairy farms, look, it's 4 to 5 times higher than the sheep and tillage farms. It's just the nature of the production, intensity of production of dairy farms. Something like the other systems are generally the same, or 140, 150 tons per farm. Something I want to highlight there, and you can see it in the red circles below, is that even though they're classified as sheep and tillage farms, they have a significant cattle enterprise, and a lot of the emissions on these farms are being driven by that cattle enterprise as opposed to their main output of sheep and tillage. This is the trend, the farm level trend through time over the 5-year time series. Okay, we saw a decrease from a decline in 2022 from 2021. But the long-term kind of 3-year rolling average is upwards. So if we see a decline in 2023 next year, we'll start to see that trend declining. On the non-dairy farms, it's been static. It's not slightly declining towards. It's actually been declining towards in the time series. The overall fact, when you combine the dairy and the non-dairy, it's slightly up because the declines in the other systems is not quite enough to offset what's happening in the dairy side. We are seeing some green shoots in 2022 on the back of reduced chemical fertilizer use, down by 16%. So year on year we are seeing a decline on the dairy and all other sectors. Okay, the gap between the dairy and other systems is not, when you do it on a per hectare basis, GHG per hectare, is not as large as it is on a farm basis. Why? Because earlier I showed you that dairy farms have much larger farm sizes. So we're seeing that on a per hectare basis, they're about double what the cattle are, and maybe 2 to 3 times what the sheep are. So it's not as stark as at a farm scale. And again, if you look at the time series, it's trending up slightly. Again, we're seeing a decline in 2022 versus 2021. But that trend is to continue in 2023. We'll see a downturn in the 3-year rolling average time series, which is positive going forward. Again, the non-dairy systems have been declining generally over static slash declining, slightly declining over the time series. Okay, so look, we've seen basically the majority of the emissions, like at the farm scale, the dairy farms are generally a lot more emissions than the cattle farms. And okay, 2022 aside, like what's been driving those increases in absolute emissions. Essentially, we can break the dairy emissions down into 3 components. Okay, the first component is the kilograms of milk produced per cow. So we're looking at the standard kg of milk, fat and protein corrected. 4% fat, 3.3% protein. So we can see over the time series, farmers are actually producing more milk per cow, which is an efficiency gain, which is positive. That's a good news story. The second component driving absolute emissions is the carbon footprint of the milk. So again, over the time series, we're seeing the footprint of that milk being produced with a lower carbon footprint. So again, that's a good news story, that farmers are producing milk more carbon efficiently over the time series. But it's the third part which is actually driving the overall emissions. It's the herd sizes. I suppose since quote abolition, we're seeing a year-on-year linear increase in the average herd size on dairy farms, and this I suppose this is overriding what's happening on the other two components, the kg of milk per cow and the footprint. And the thing is, if we didn't do improvements in the first two, then the overall emissions will actually be higher. And the efficiency gains are offsetting some of the increase in herd size. On the sheep and cattle side, look, on the footprint side, we're generally seeing a decline over the a reduction in carbon footprint of beef and sheep meat over time series, which again is a good news story. Farmers are producing product more carbon efficiently. But it's just something I want to highlight, there's massive variability within the systems in terms of top, middle, and bottom, how carbon efficiently they're doing it in terms of some of the bottom economic performers have double the carbon footprint of the more efficient producers. So that's something that's one to highlight the heterogeneity that's within these results. Okay, so the second gaseous dimension is ammonia. So again, we're reporting emissions per farm and per hectare, which is the absolute level, and we're also doing it on a per kg of output and per year of output, which is the footprint of the ammonia emissions. So again, on a farm basis, dairying 3 tons per farm, which is slightly up from the previous year. It's below the long-term trend, but slightly up from the previous year. Why is that? Because we saw farmers because of fertilizer prices buy more straight urea than heretofore, and that's a very very high ammonia emissions. The protected urea was up, but so was straight urea, and this offset some of the gains we achieved from low emission slurry spreading and so on. Again, it's 4 to 5 times higher than the non-dairy, the other systems, dairy, sheep, and tillage, or cattle, sheep, and tillage rather. And again, I want to highlight the sheep and tillage farms, that a significant amount of the ammonia is being driven by the cattle enterprise on those farms. So the long-term trend on ammonia is actually positive. We've been seeing declines year on year for the last couple of years. Okay, with a bit of a blip on dairy farms in 2022. Again, it's due to the fertilizer that was applied, straight urea versus the lower protected urea fertilizers. But the long-term trend is declining. Hopefully, we get back to that in 2023. The non-dairy farms also showed a decline in ammonia in 2022 and long-term time series. Again, on a per hectare basis, the gap between dairy and non-dairy isn't as significant, again, because dairy farms are larger, significantly larger in terms of farm sizes. But dairy farms are about double what the cattle are and 3 times what the sheep are. And again, the long-term time trend is that those emissions on a rolling 3-year average basis are going down, notwithstanding what happened in 2022. So that was just a blip. I'm gonna coming towards the end here, but we do report some indicators that look at risk to water quality, and it's the main two in terms of the source pressure are nitrogen and phosphorus balances. How do we do that? It's basically an accounting approach where we track what's coming in to the farm gate in terms of how much nitrogen is coming in, phosphorus, how much is coming in, how many P and K is coming in fertilizer and feeds, organic manure, and seeds and so on. And then what's going out the far side in terms of how much N and P is going out in product, milk, meat, crops, and so on. One minus the other gives you your surplus per hectare. And all other things being equal, and that's a hugely ubiquitous statement when it comes to water quality. All other things being equal, the lower the surplus, the lower the source pressure locally. But we know water quality is hugely dependent on the local biophysical conditions like soils, hydrology, weather, as well as the source pressure. We also look at nitrogen phosphorus use efficiency, which is how much, it's kind of an agronomic measure, how much of the nitrogen and phosphorus is being captured in product. So the more we capture in product, the less is available for loss to the atmosphere or to the aquatic environment. Okay, so the end balance, you're essentially looking at what's coming in inputs, what's going out in outputs on a per hectare basis. And the results for 2022, again, we're seeing a differential between dairy and the non-dairy systems about 3 times higher. But the 150 is actually a significant decline on previous years. It's been declining since about 2018. We're seeing a decline where it was up around 200, it's down to 150. So in the last couple of years, we're seeing an improvement in the downward trend, which is positive. Also on the non-dairy systems. So it is. I suppose there are incentives there in terms of fertilizer price. Farmers are tending to be using their fertilizer more efficiently. This is reflected also in the nitrogen use efficiency. Dairy farms are hitting close to 30% now in 2022, and the long-term trend is upwards. So there's massive incentives there with fertilizer price and so on to farmers to optimize here, and that was seen by reduced chemical N, and farmers have been transitioning towards clover and multi-species storage and so on as a hedge against these fertilizer prices, which is improving economic performance. Finally, the last leg of the stool is a stabilizer. So I'm going to touch on some innovation indicators. We're strongly promoting things like low emission slurry spreading and protected urea in the Teagasc MAC, and we've seen a massive increase in the amount of slurry being applied by low emission slurry spreading in recent years. So in 2022, in 3/4 of all dairy slurry and nearly 1/3 of cattle slurry was applied by less, which is significant ramping up from what it was in 2017, which was basically minimal. So on the back of regulation and advice, that's farmers really embraced that technology. Less so on the protected urea, unfortunately. Okay, it's going in the right direction. In 2022, about 14% of chemical N on dairy farms was applied via protected urea. Less so on cattle and sheep farms, but really need to get that message out there that protected urea needs to be applied, because it is a significant reduction in ammonia emissions, which we're on the hook for. Okay, so to summarize, on the economic and social metrics or dimensions of legs of the stool, dairy performs strongly in terms of the farm and per hectare, more so than the other 3 systems. But when you do it on a per unit of unpaid family labour, the tillage farms are actually quite comparable to dairy farms, because dairy farms have a lot more family labour in their 1.5, 1.6 labour units compared to about 0.9 for tillage. Tri-stock systems, look, they're challenged on the economic side and they're challenged on the social side for a number of reasons. In absolute emissions in 2022, we saw a decline in 2022 back to 2021 levels, and it's basically due to reduced chemical N, and fertilizer prices were off the charts in 2022. So the incentive is there, and farmers are realizing that things like clover and multi-species are a hedge against these fertilizer price shocks, which are external, which are very geopolitically dependent. The other farm systems also showed a decline, again driven by on a per farm and per hectare basis, again driven by reduced chemical N fertilizer use mainly. On the ammonia side, look, we did see an increase on the dairy side, which is unfortunate, and it's basically down to the use of straight urea, kind of offsetting what was being made on the other side in terms of the low emission slurry spreading. And other systems have showed a decline on a per farm and a per hectare basis compared to previous years. Look at the carbon footprint of the carbon and ammonia footprint of the product, the meat and milk, is generally improving. Farmers are producing it on a more efficient basis. And on the innovation side, we're showing, low emission slurry spreading has been hugely embraced across the farming population. Protected urea remains low, and really like to get a message out to the farmers should really look at using this fertilizer going forward. So that's all for me, Pat. That's my email address. That's the link to the publication, which will be up there presently after the webinar. So I'll hand back to you, Pat.
Okay, thank you very much, Cathal. A lot to take in there. Some key messages at the end, and I suppose 2022 and into 2023 have seen some fairly dramatic changes brought about by prices and availability, particularly of fertilizer, which are having very significant impacts on the figures. And it will be interesting over the next while to see where that plays out.
Excuse me.
So thanks very much for that. Just to remind people to, if you have questions for Cathal, just to use the Q&A, and we'll come to him after the next presentation. Simon, I suppose this is a further development. What you're talking about is the introduction of biodiversity indicators, and if you present to us there, we'll get an idea of what's proposed in this area. Thanks.
Thanks very much. Thanks for having me. Can you see that all right, Pat?
Yes, that's perfect.
Great. Okay. Good morning, everybody. Thanks for the opportunity to present today. My name's Simon Leach. I was recruited as a biodiversity technologist earlier this year as part of Teagasc's new climate centre. My role is a joint appointment between the Crops, Environment and Land Use Programme in Johnstown Castle and the Rural Economy and Development Programme. I plan to provide a bit of context in terms of biodiversity and the benefits of linking an indicator with the National Farm Survey. I'll briefly recap on some of the previous development work that has been undertaken and provide an overview of how we plan to deliver an NFS biodiversity indicator. I will also highlight some of the related challenges and key data requirements for the proposed approach. So firstly, why biodiversity? We're in the midst of a widely acknowledged biodiversity crisis. A series of targets have been set in recent years to halt and reverse losses. Biodiversity is considered a key sustainability metric, although it's largely been omitted from measurement and reporting to date. Addressing biodiversity loss is a central objective of the Common Agricultural Policy, and there's increasing investment to address this and other sustainability challenges. There are also close links to the wider climate challenge and the need to maintain resilient ecosystems. For all of the above reasons, there's a high demand for better information to quantify biodiversity levels and to monitor and measure change. Currently, there's no regular, systematic, repeatable and statistically representative monitoring of farmland biodiversity in the wider countryside. Our aim is to address this gap through the implementation of a biodiversity indicator within the NFS. We aim to include data on habitats for all National Farm Survey and Small Farm Survey farms. This will provide a data set of habitat quantity and also quality on both the more economically active farms and also the smaller farms, which are associated with a higher degree of nature value. A key benefit of linking with the National Farm Survey is the opportunity to leverage combined analysis with other metrics captured in the survey. As we develop the methodology, the aim is to make best possible use of nationally available datasets and existing resources, maximizing efficiencies and economies of scale. The approach will also be designed to be repeatable, making use of data updates going forward to assess change over time. A number of projects undertaken in recent years have contributed to our current work plan. Ideal HNV assessed Ireland's landscapes to identify the distribution and extent of agricultural land of a high nature value. Better understanding the distribution of these HNV systems can facilitate better targeting of resources, prioritizing reinstatement of habitats in lower nature value areas while placing more focus on quality improvements in regions of higher nature value. Capturing biodiversity information for the Small Farm Survey as well as for the National Survey will ensure that these high nature value areas are adequately represented in the data. At farm scale, pilot projects such as smart agri-hubs have developed the use of farm habitat indexes. Farms were scored and ranked based on the extent of different habitats, taking account of their relative value in supporting biodiversity. Lower scoring farms, such as the example on the left, are generally dominated by improved grassland and intensive systems. Areas of semi-natural grassland and woodland, indicated by the areas of purple and brown hatching in the middle example, increase the index score as they provide more diverse and natural areas. The upland farm on the right includes large areas of wet heath and blanket bog, while the grassland is entirely semi-natural and achieves a higher index score as a result. Habitat mapping for this scoring was undertaken via manual image interpretation, which can quickly become prohibitively expensive. The release of the National Land Cover Map in March of 2023 provides a nationally consistent source of mapping. With a reference year of 2018, the classification scheme is closely aligned with the widely used Fawcett system. Part of the Farm for Bio project engaged expert contributors to define a conservation value score for each of the land cover classes. By combining these national mapping with such a scoring system, we can present conservation values within a range of geographical frameworks, such as the electoral districts, which are shown in the inset image. The land cover mapping delineates the agricultural landscape at parcel scale and captures hedgerows, tree lines, and other habitat features. By extracting the land cover information for NFS farms and assigning conservation value scores for these land covers, we will be in a position to generate a measure of the quantity of habitat at a farm level. Accurate definition of farm boundaries is a key data requirement for this process to ensure that metrics reflect all land managed under the contributing holding. A biodiversity quantity metric can be generated, and the outputs will also aid the targeting of subsequent field survey efforts. Understanding and monitoring the quality of habitats is also important. The structure and species diversity of a hedgerow, for example, will have a huge impact on its biodiversity value. We plan to design and implement a targeted field campaign to measure habitat quality for a selected subset of habitats. Scorecards, such as those developed in the Farm Ecos project, will likely be employed to aid efficient data capture. The aim will be to produce a dataset from which we can evaluate the range and distribution of habitat quality, both across and between farms and farm categories. Both the quantity and quality methodologies will be designed to be repeatable to facilitate assessment of change over time. As we develop and implement these surveys, we will review and document the strengths and weaknesses of the approaches and the data sources. There will be particular focus on the degree to which the National Land Cover Map can contribute to the wider monitoring of biodiversity. We will work to better understand the impact of data accuracy at farm level, learn more about Land Cover Map update plans, and fully evaluate the capacity for the detection of change over time. We'll work with partners and stakeholders to establish ongoing data sharing and access agreements to fully embed the biodiversity metric into the National Farm Survey. Associated work will be undertaken to better understand the spatial scale of landscape changes that result from policy and management interventions, as well as the timescales over which these changes can be effectively measured. The biodiversity indicator will provide a mechanism to track habitat quantity and quality within the nationally representative framework of the National Farm Survey. Ongoing review will aim to refine and develop the methodology over time, but the fundamental aim is to build and maintain a representative, robust, and repeatable indicator for farmland biodiversity. Thanks very much. That's my material.
Okay, thanks, Simon. And I suppose a question that springs to mind in relation to the work on biodiversity is the sample that we have in the National Farm Survey is it representative of the areas in which we have, if you want, high nature value or upland areas and some of our I suppose lower intensity farms, or will it require I suppose a fundamental change in the farms that we have within the survey, or is that a too difficult question to answer at this stage?
Well, I believe that's where the small farm survey comes in and provides the important link to those higher nature value areas. There's a focus on larger, financially larger farms in the main survey, but the small farms survey provide that balance.
Yeah, I think that, I mean, the NFS is almost 50 years old, and it's part of the FADN, so it primarily has traditionally been focused on the economic objectives, but as we've demonstrated here today, we are now looking across the 3 dimensions of sustainability, and our work has been at the forefront in driving that development at a European level. And for certain, as society places more value on the non-market output of agriculture in terms of landscape provisions, services, so on, and particularly services provided by land uses that are much less productive in terms of producing food outputs. And as policy gets more important in supporting those type of activities, the focus will shift towards more measurement on those type of areas. But it's very difficult to jump quickly and immediately into doing that. So we have had a small farm survey in the field. We had one in 2015. That our plan is to repeat that on a regular basis, not on an annual basis, but on a regular basis. And as the law changes, if the law changes to say that we must measure all those small farms that are producing less food, but may well be producing more biodiversity habitats or habitats of better quality, we'll respond to the demands of society.
And I suppose a follow on the changes that have happened in acres versus the previous agri-environmental schemes, particularly in the upland and in the CP areas. I presume there is an advantage if we can get data sharing to be able to analyze the scores that are coming through and the data that's coming through and to leverage some of that.
Yeah. Everything that we do in the National Farm Survey, and I'm sure Cathal and Trevor will want to comment on this as well, is based on the voluntary participation of farmers. And there's a number of questions that have come in from the audience about, are we measuring, or do we have information on different types of farms that we've talked on here today? And we will work to expand the set of farms that we have measurements on, but we will need the cooperation of those farmers. It's all on a voluntary basis. And the same thing goes for farmers who are smaller in economic scale, but may have a bigger environmental or ecological input. So we will do that. And our indicator set development then is always done in tandem with our animal and environmental science colleagues and with the best economic science as well. And, while it might seem very straightforward and sensible, it takes an awful lot of work to get to where we will need to get to over time. So, so on the surface, Cahill's presentation was like a swan. The usual analogy is calmly moving across the water, but there's an awful lot of work going on underneath that's necessary to provide these annualized indicators, and particularly ones that, as Simon stressed in his presentation, are statistically robust and actually are meaningful in an economic sense, in an environmental sense, and in a social sense. And it might be great to do it once, but that's of value for certain in telling about what's going on now. But we need to basically have a vision of what's happening through time and across space and across different types of farms. So it has to be repeatable to give us that perspective on are we making progress? Are the policies that we're implementing as a society doing what we want them to do? And what are those things that we might want to consider doing to make things better, be that environmentally, socially, or economically? Okay.
Okay, Kevin, a good few questions coming in from the audience.
Yeah, I mean, I'll take the first one. I think let's do it chronologically, Pat. That I'm not sure how you usually do these things, but we've presented here today on 4 systems using the National Farm Survey data: dairy, cattle, sheep, and tillage. And there's a question about do we have horticulture? Are we collecting data on pigs? And so on. And just to go back what I commented a few minutes ago, we will always work with we need the voluntary participation of the farmers to have the data. So we have research projects on just about to start on collecting or trying to collect equivalent data that we've seen here today for the horticulture sector. So we have an ambition to have something like this in a number of years' time on the horticulture sector and its environmental, economic, and social performance. But again, it's conditional on that cooperation of the farmers. So that's something we're definitely working on. Horticulture isn't part of the tillage sector, so it's distinct, okay? On pigs, we are collecting data within the FADN, for our FADN requirements from pig farms with the cooperation of pig farmers. We will need to work with our environmental and animal science colleagues to come up with meaningful metrics about how do you measure the environmental performance of pig farms. So pig farms on a per hectare basis, does it make sense to think about them on a per hectare of the farm's area when many of these farms are importing their feed from other farms predominantly? So we need to think through those things. Again, we'll be working with our environmental and animal science colleagues to actually come up with a meaningful metric economically, socially, and environmentally.
Okay. A question here in the context of environmental sustainability. I know that you look at mitigation and protection of biodiversity, but should this not also include climate change adaptation? And is it being considered going forward?
Trevor, do you want to talk about the new project that's about to start?
Yeah. Yeah, I mean, it's a very relevant question. Up till now, and we can say this in across all areas of the economy, the situation has been that it is mitigation that has taken priority over adaptation. And I guess you could argue to some extent that without mitigation, there might be nothing there to adapt in the future in the context of agriculture. So I think it's understanding. It's understandable that the focus has been on mitigation. I think some actors as well have been concerned about a focus on adaptation because they see it as giving up the ghost in terms of the pursuit of emission reductions under mitigation strategies. So some people have actively discouraged the pursuit of adaptation for that reason. But to get on to the main point, Teagasc has hired a number of people now as part of its virtual climate centre. So one of those people, our colleague Lorraine, will be looking specifically, we hope, at this issue of adaptation. She's produced a project proposal on that, which is going through an external evaluation in terms of whether it will go ahead. But I'd be quite confident that it will. So that will look at adaptation. It will also look at wider areas of resilience as well. To not just to climate shocks, but to other types of shocks as well that we increasingly see. I only have to mention, obviously, the dramatic increase in input prices that we've seen over the last couple of years. So that wider resilience issue is something that we want to try to capture as well, not just resilience to our the ability to cope with the types of change that might come through changes to climate. So that is something that we will cover as well, and we'll do that across the principal farm systems initially, and we'll also engage with farmers to try to understand their attitudes to both mitigation and adaptation measures.
Might just come in there. Might just come in there as well in terms of we're working with colleagues in the agri program at UL in particular in terms of climate. Trying to project what future climate scenarios look like. Working with mid-air because if we kind of have to know what we're mitigating against, what's the different climate scenarios. So we have a project, proposal funded under review with part of agriculture at the moment to try and first of all model what the different streams would be, and then look at how we mitigate some of those extremes or less extreme scenarios.
There's a question. The next question on the list is about the economic sustainability of Irish farms compared to other countries in the European Union and in the UK. And there's lots of research going on, other than that presented by Cathal and Trevor here and Simon in rural economy. But one of our colleagues, Fiona Thorne, has worked on this question for a long number of years. Let's put it like that. And I think sort of the comparative story that Cathal told within the NFS data, when we think about how we compare against European or British peers, we're generally speaking trying to compare apples with apples. So we're comparing dairy farms in Ireland with dairy farms in other countries in the European Union, tillage farms in Ireland and beef farms in Ireland, sheep farms. I think as a general statement, our dairy farms are very competitive economically. Our tillage farms tend to be quite competitive, but the dry stock enterprises tend to be less competitive in an economic context than our European peers. The FADN is a standardized data set, and the great value of that data set is not only that it's statistically representative of the member states, but that it allows you to compare the economic metrics between member states for well-defined farm systems. So Google the FADN and you will find summary reports that show how Ireland and Irish farms compare with their peers from all the other member states. The UK, unfortunately, has left the European Union, and while you'll find the historical data that compares our performance with Great Britain and Northern Ireland, you'll have to start digging out farm business survey reports from those that other country as we move forward through time.
Another unfortunate consequence of Brexit, which you've talked a lot about on webinars. Question or a comment and a question, basically saying that efficiency is of no real value in terms of greenhouse gas emissions if they're increasing. How can we effectively reduce greenhouse gas emissions to meet our objectives going forward?
Well, I think people think that productivity isn't important for climate change or environmental purposes. They really need to think about how they think about the world at large. I mean, it's very important. Even if emissions were going up, if we weren't getting productivity improvements, emissions would be going up even more. Okay, thankfully, emissions at the moment are not going up at a sectoral level from agriculture. They're relatively stable. So we want to see that footprint improve over time. But the legal requirement is that the sectoral emissions fall. So the type of things that Cathal talked about in his presentation that are in the Teagasc map, collectively across the sector, with government and with industry, we need to see those things happening. And I guess that's what the Signpost program is all about, Pat, is trying to get the message out there and show how it is eminently feasible for most of these measures to be adopted by farmers and to be adopted quickly. And the more quickly they're adopted, the more progress we will make towards our 2030 target.
So, and I suppose coming to an issue that Cathal raised in relation to fertilizer type, and it says with protected urea being such an easy win, why are we not having, or why are non-protected fertilizers allowed to be sold? I don't know this is beyond the scope of anybody at this, but I suppose it does point to, I suppose, a question that you raised, Cathal, about the speed at which we are getting a shift over to protected urea, and in particular, the almost a pollution swapping, where over the last couple of years, because of availability, we've seen a massive shift in the type of fertilizer being used, with a big shift over to urea, but it not being particularly to protected urea. That's a challenge, I think, isn't it?
Yeah, it certainly is. In terms of, there has been supply chain issues, I think the industry needs to come together really. Teagasc have done the science. We know it works. There's no residues. We know it does what it's in the Teagasc map for a reason. So we just need to get on and get it implemented.
I suppose a technical question there for nitrogen efficiency. How do you factor in purchase feed, and where are the sources, production amounts used? How are they factored into your calculation?
Yeah, I suppose from a nitrogen surplus perspective, it doesn't really count where the feed comes in. It just calculates the quantity of nitrogen in that feed. Now, from the greenhouse, we do LCAs from a greenhouse gas perspective, which accounts for, if that soya is coming from Brazil and the carbon footprint of that. So, we do track that from a GHG perspective, but the accounting framework, doesn't really do from a farm gates perspective. We may develop down the line in terms of a nitrogen flow scenario. We do pick it up in the greenhouse gas side.
Okay. Question there, how does the carbon footprint that you calculate compared with data published by Board BIA from their quality assurance?
So the carbon footprint numbers I present today were based on IPCC methodology. This is how our national inventories are calculated. We also publish, it's in a report, an LCA number. In previous years, I put up slides comparing our number to Board BIA. We're actually transitioning at the moment from it's a bit of a technical point. We're transitioning from an economic allocation to a biophysical allocation. So the models are actually in the midst of changing. That's the reason I didn't cross-site here. We expect the numbers are going generally in the same direction. They're not exactly the same, but they are going in the same direction. And next year, I expect to be able to cross-site again when those models are aligned again.
Okay, a question here, I suppose, looking forward, in what year do you expect Teagasc report to include greenhouse gas sequestration at farm level? A lot of work to be done before that can happen.
I think there's an awful lot of work needs to be done by our environmental science colleagues. And again, back to banging the drum about how this work in terms of indicators in the sustainability report really does leverage off of collaboration with people in CELOP. And once we've got the hard science, environmental science done, then we'll do the even harder economic science that sort of tries to integrate them together with the sort of the human factors that affect the emissions you get or the sequestration you get at a farm scale level. But it's tricky stuff, and we're not going to rush into it just for the point of being seen to have something done.
So yeah, so it's and I suppose a lot of work being done at the moment in relation to the carbon observatory, where a lot of data is being gathered on the emissions and the relative losses and gains into soil carbon. So as you said, a lot of work to be done there. Is there a potential to look at and link the work that's being done in relation to the water indicators that you have, to link that to some of the outcomes in terms of river catchments and impact on water quality, as opposed to just dealing with nutrients on their own?
Okay, it's possible, Pat. Again, it goes back to what data we have available. Can we get access to things like AIMS and LIPUS and model where the farms are spatially and what systems and how they're managing their fertilizers? So look, there is a potential there to do some kind of spatial matching to model where the source pressures is. Like go back to the point about water quality. Like hugely, we've seen from the agricultural catchments program. The soils, the hydrology, the weather are hugely, effectual in terms of the nitrogen losses. It's not just the source pressure, because some of the more intensive catchments can handle, catchments can handle high surplus versus another place which can't. Like, so it's really down to look at the biophysical environment of what kind of source pressure and the biophysical environment can handle.
Question here, and probably a fairly important one and a fairly challenging one. Are there any plans to measure ecosystem services?
Well, I would argue we've kind of started to do that now. We have a PhD student working in the Burn who's trying to do it from a small scale basis. So we start from there and work out. But look at it's hugely challenging. And again, I saw in one of the questions in relation to we're not capturing stuff like biodiversity or recreational benefits, which is true. And someone who's worked in non-market valuations, it's very, very difficult to capture those kind of non-market benefits. But that said, like what the work of Simon has been doing with John Finn and ourselves, like those high biodiversity areas tend to correlate with the high recreational areas. So in a sense, you could probably use it as a bit of a proxy if you overlay it with maybe recreational areas to try and capture the direction between that and recreation.
Okay. A question here, is there a correlation between improved environmental and economic sustainability on farms?
Yeah, that's a tricky one. I would say there's a correlation between carbon footprint and economic performance, but to be honest, it probably goes the other way with absolute emissions. You know, we've seen like we're a bovine-based agricultural system. 70% of the emissions relate directly to the animal. You know, until such time as we can address methane, and people are actively chasing it, like feed additives and so on. Like, you know, until such things that we can address that, like, you know, the link is not really established in absolute terms. It is for carbon footprint.
Okay, a comment here first. Thanks for the presentation, Cathal. Why do you think there is such a difference between adoption of less compared with protected urea? And a question, is it driven by contractors?
Well, the short answer in terms of regulation has been driving the less, to be honest. You know, it started under the Dry Test Directive that irrigation farmers had to do it, and that's been extended. And contractors obviously purchase the machinery to service those farmers, and then they use it probably on the non-irrigation farmers. So that's primarily been driven by regulation, but also TAMS grants. You know, there was significant capital grants there to purchase the machinery. Less is voluntary. And look, there's been supply chain issues, and I think we covered it already, Pat. Like, but we really need to get our act together when it comes to protected urea and get it adopted.
A question here in relation to anaerobic digesters, and again, it may not be something that you're one to comment hugely on, but anaerobic digesters and the creation of a biomethane industry in Ireland has been flagged as a game changer in relation to dairy farming. To what extent do Teagasc see such a development playing a decarbonisation role in the dairy sector?
I think that's a challenging one, Pat. I mean, there is other research ongoing, which may well be the subject of a subsequent signpost seminar on that specific topic. I think the short answer, and I don't want to preempt the results of other people's work, is that you know, this may be a viable alternative to some parts of agriculture, but the sheer profitability of dairy farming means that that's probably not where we're going to see a transition coming. You know, so I think it's going to be more dry stock farmers that will engage with that technology. Certainly, dairy farms could be a source for slurry, but in terms of the grass silage, I think that's more likely to come from dry stock farms.
A question here for Simon. We haven't questioned yet to any extent. Simon, is there a balance to be had between acceptable biodiversity levels and sustainable output from farms? Farms shown in your example goes from one extreme to another, I suppose, with upland and productive lowland. So I suppose what they're asking is, how do we balance and assess biodiversity in the context of production levels on the farm? So you're on mute there, Simon.
Certainly, those examples were designed to show exactly that there's a full spectrum of biodiversity levels across different farms in different parts of the country. And as Cathal said in his presentation, there's always a need to balance economic sustainability and other elements of sustainability with the biodiversity side. But I think there's always an opportunity to focus and try to improve biodiversity status in the landscape, whether you're in a more intensive area or you're farming in a high nature value part of the country. So whether you're focusing on reinstating and adding features to support biodiversity into an intense landscape, or whether you're focusing on improving the quality of existing habitats in a higher nature value area, I think that there's a balance to be had, but there's always an opportunity to make improvements too.
Yeah. Cathal, there's a question in relation to the labour efficiency and the amount of labour, particularly on dairy farms, and I assume part of the trend over the years has been the increase size of those units. But I suppose a question there is the availability of labour for dairy farmers becoming an issue in, I suppose, a more unsustainable system whereby they're not able to get outside labour to work.
Anecdotally, Pat, that seems to be the case. We do track like the kind of paid labour as unpaid labour, and you know there has been more paid labour employed on dairy farms over the time series. I suppose look at in a full economy, it's hard to attract. I suppose it'd be hard to attract people into the dairy into the agricultural sector. To be honest, but the concerning point for me, and as I raised in our presentation, is the amount of hours being put in on those dairy farms by farm families and farmers in particular is trending upwards, and you know it's from a work-life balance perspective has to be questioned.
Okay, there's a question there, and again, it'll be a difficult one to answer. It alludes to the achievement of the measures in the MAC, getting our 25% reduction, and if we don't, what kind of levels of fines are possible from the EU in relation to not achieving our targets?
Yeah, I don't think I mean there are budgets in place already for the entire economy. I don't think there's going to be a specific budget for GHGs associated specifically with the achievement of the 2023 MAC. I mean, the best way to think about this concept of a budget is to imagine it to be a box of sweets that you might have there at Christmas time, and progressively each year the number of sweets in that box is going to get smaller, and that's something I think we've all experienced in recent years. And it becomes a question then of how you use up the sweets in the box and how quickly you do that. And if you eat more sweets the first few days, you'll find that there's fewer sweets left subsequently. So at the moment, what we're doing at a national level in Ireland is we're eating the sweets too quickly, and that will mean that our efforts or the pain involved in reducing emissions will become more acute as we move further forward in time. That's assuming that the targets are actually ultimately to be achieved. I can't comment specifically, Pat, on what fines would be involved towards the end of that period for non-compliance.
I think the Fiscal Advisory Council had a report out yesterday, the day before, that pointed to it being a risk if the economy as a whole didn't make the reductions that are in our European effort sharing regulation commitments. But the National Act and the 25% target that the agricultural sector has, I think that's the minister can be brought to court under the law if that isn't met, as can other ministers of government who have a responsibility for the other sectors that are also behind the curve in terms of living within their budgets. So we don't know yet, I guess, is the simple answer.
Yeah. A question there about is there any link between what's been done in terms of the biodiversity indicators with the Department of Agriculture pilot farm environmental study and the development of our indicators?
Go on, Simon, let you answer.
Sorry, there's no direct link with it. I imagine my understanding would be that the pilot study would be about KT and developing understanding and practice. Our focus at the moment is obviously it's in the same area, but it's about developing a representative indicator to look at the status on farms nationally.
So the people in the Department of Agriculture are starting a research project that will be looking at this, but on a nothing like the kind of sample size that we're working with within the National Farm Survey. But they're using it because they have a requirement under the CAP to have an evaluation metrics for the things that they're doing within the CAP strategic plan. So we'll see how they get on with that, and they certainly are fully aware of the work we're doing, and we're being kept abreast, both as the economists in Teagasc and as ecologists and environmental scientists, about how they're designing their evaluation project. So it's there's cost of fertilization, but they're not directly linked, Simon said.
If I'm correct in this, and if the questioner is correct, you noted I suppose an improvement or a decline in vulnerability across a number of the sectors. But the question is the decline in vulnerability of those farmers more down to what's happening on the farm, or is it, I suppose, better employment and off-farm factors that are contributing most to that?
It's a combination of those factors, to be honest, Pat. So we saw some higher prices in previous years, which brought some of those dry stock systems who were marginally at the edge in terms of being economically viable or not, put them over the edge. With slightly increase in off-farm employment, like there's a lot of off-farm employment opportunities. We're full employment now, so it's really a combination of both the on and off-farm situation. That's the household level, but like a lot of these people have either a spouse or the farmer themselves are working off-farm, particularly in the dry stock sector.
And a question there in relation to succession and age structure. Have we any indicator as to whether the age structure within the various enterprises is getting older or younger, and whether there's an improvement or disimprovement in the availability of a successor to continue? But I suppose both are key aspects of long-term sustainability of an enterprise at farm level.
Yeah, I mean, I think that across the sectors that we've talked about here today, dairy farming would have the lowest age profile, and the dry stock sectors would have the highest age profile. So it's a tricky question, in the sense that if we want to rejuvenate farming, it needs to be an attractive proposition for young people who are considering what they're going to do in terms of their working lives. Because the overall population is getting older, and dry stock farmers have higher isolation risk. They're older farmers in general. So but trying to persuade people to take up farming as effectively a lifestyle, or as their preferred occupation, there has to be living in it, and it's about how you either create a living on a full-time basis for a farmer and his or her family, or create systems that are combinable with work off the farm. And for many farmers and farm families, that is the reality in 21st century Ireland.
Listen, I think we've come to the end of our time. Really fascinating, and I think probably, Cathal, what you have presented is the tip of the iceberg in terms of the data that's available in the report. It's becoming a very deep dive into the sustainability and the development of sustainability on Irish farms. I think it's going to increase in importance as we go forward. So I'd just like to say thank you to all of you for your presentations and for the answering of what are a very broad range of questions, some directly related to the survey itself, and some to broader industry issues which may be challenging to answer. So thank you very much for your contributions there. Just to remind you that once again that the webinar this morning is I suppose the start of a series of Signpost Sustainability Month events, which you can find by Googling Signpost Sustainability Month and get a list of the events that are going on. Next week on a similar topic, we'll be joined by Stuart Gee. He's a designer and producer in EIP Climate Kick, and he'll be looking at innovation as a driver for climate action in the area of carbon farming and sustainable dairying. So we look forward to that at 9:30 next Friday morning. So thanks for staying with us, and hopefully we'll see you next week. Goodbye.
Bye-bye.
Bye-bye.